We are the CSI agents on this case, and we have pulled out all the steps to ensure justice is done to the victim. After weeks of experimentation and evidence collection, with the power of mathematics, we have gathered enough information.
Our hypothesis for the experiment is the greater the height the blood was dropped from, the wider the diameter of the blood stain. Here are our assumptions, which were made to ensure our results are as reliable and as accurate as the actual crime scene as possible.
This is the procedure we followed. We measured height of X centimeter from the surface of the ceramic plate and then positioned the tip of the dropper at that height. Then we gently squeezed the blood out of the dropper, applying a slow force with minimum pressure to let the blood drop fall off. Then we measured Y centimeter, which is the diameter of the blood stain, ensuring that it was formed in a circular shape. Steps 1 to 5 were repeated twice for the same height, and then the average diameter was taken. Steps 1 to 6 were repeated for other heights of X centimeter, with at least 10 sets of data for heights between 25 and 160 centimeter being recorded, all of which are in the table as follows.
From the table, we can see the overall trend of when the height from where the blood drop increases, the diameter of the blood spatter also increases. We have an anomaly of 1.70 cm diameter of blood stain when the height was 115 cm. For all three graphs, the independent variable, also known as the x-axis, is the height the blood was dropped from, and the dependent variable is the diameter of the stain, the y-axis. The R-squared value is also known as the correlation coefficient. The closer the value is to 1, the more accurate the graph is in representing our data.
Our first graph, which is the linear graph, gives us the best fit line for the data for y equals to mx plus c equation. The graph has a R-squared value of 0.772 rounded off to 3 significant figures.
Our second graph, which is the power model graph, representing y equals to ax to the power of b, which gave us our exponential curve for the values. The R-squared value is 0.791 rounded off to 3SF. This graph has a generally positive gradient, which supports our hypothesis.
Our third graph, known as the cubic graph, has an R-squared value of 0.869 rounded off to 3SF. This graph has a generally positive gradient, which supports our hypothesis. Overall, our best fit mathematical model is the cubic graph, as it has the highest R-squared value of 0.869.
According to the employer of the maid, she was seen squatting on the floor with blood dripping off her elbow. However, this does not correlate to our data. From the table, it is shown that the diameter of the blood splatter was 1.8 cm when the height was 100 cm. Hence, the employer's claims that the maid was squatting on the floor when she was shot is wrong, since she cannot be squatting on the floor at 100 cm above the ground. Therefore, we support the lead detective's suspicion, and the employer will be taken in for further questions.